problems. You are either going to be given something that is, basically 2 points and you can write an exponential equation of it, or you might often also be given an exponential growth or decay equation. Sometimes they deal with finance, not always, but often they deal with finance. If they say that in the case of the first one, the first example, that the, oops, wrong thing. The first example that it compounds continuously, you're going to be using the equation A equals P times e to the RT power, where A is the amount of money in the account after a given time, P is the principal, which means how much did you put in to begin with, E of course is Euler's number, R is the interest rate as a decimal, and T is the time, which in this case is number of years. So T is in years. If instead they say it compounds annually, A equals P, and then if it only compounds annually, well, it's 1 plus the rate. So if it's 6%, this would be 1.06 to the number of years. But if it says it compounds monthly or 365 times a year, which is daily or something like this, I have to say I take the rate and divide it by, if it's monthly, divide it by 12, because they're not going to pay the entire rate each time. They're going to pay a 1/12 of that each time. And then this is the number of times it's compounded over the life of the loan. Well, it's compounded 12 times per year times the number of years. If it was compounding 365 days a year, then this would be a 365 and that would be a 365. So, continuously, she's 22 years old and hopes to retire when she's 57. So I'm going to use the A equals P times e to the RT power. She wants to invest $20,000, so her principal is $20,000. And she wants to have $100,000 at the end. So what she wants at the end, what she wants to invest, they want me to know the interest rate. Well, if she's 22 and she wants to retire at 57, then 57 minus 22 gives her 35 years to do this. Now, it's not that you can retire on $100,000. This is just supplementing something. So this is going to be to the 35 times R power. Now I have to solve this. First, I divide both sides by 20,000 to isolate the thing that's being raised to the exponent. 100,000 divided by 20,000 is 5 equals e to the 35 times R power. I'm stuck. I'm stuck in exponential form. So when I'm stuck in exponential form, I convert to logarithmic. This is a base E logarithm, though. So a base E log, which is the natural log, of 5 equals 35 times R. So R equals the natural log of 5, and then divide by 35, which means R equals 0.046. So I would need 4.6% interest rate to be able to take it from 20,000 to 100,000 in 35 years. This is a case where it's not the normal sort of thing like that was, investing money. Oh, but they do give me that 2 different temperatures and 2 different times. Because it says that time depends on temperature, remember x is your independent variable and y is your dependent variable. So time depends on temperature. If they didn't tell me that, then I wouldn't know which way to put that, but you know from science and from math, y is your dependent variable. So I have 2 ordered pairs. The first temperature, because x is temperature, is 4, is 4, and the time that goes with that is 146. The second temperature is 22 degrees, and the time that goes with that is 42. Now I go back and I just use these 2 points to write an exponential equation. You know I prefer to have my largest exponent first. So that y equals a times b to the x. Y is 42, equals A, which I don't know, times B, which I don't know, to the x power, so to the 22nd power. So y equals A times B to the x power. And I'm going to divide these two. So 42 divided by 146, I don't want to round that yet because I can. It is a rational number. I can just reduce that fraction to 21 over 73 equals, the a's would cancel, b to the 22nd divided by b to the 4th is b to the 18th. So to find b, I'm going to have to take the 18th root of 21 over 73, and the 18th root of 21 over 73 to 3 decimal places is 0.933. So now I'm going to take the easiest point, which is probably the second one, I don't know, y equals a times b to the x power. So again, I'm not going to round any more than I have to here. A equals 42 divided by 0.933 to the 22nd power, which means to 3 decimal places A is 192.675. So my final equation, y equals 192.675, oh my goodness, times 0.933 to the x power. Real life problems get nasty in a hurry. Use the equation to predict how long milk will keep at 30 degrees and 16 degrees. Well, the temperature is my x, so y equals 192.675 times 0.933 to the 30th power, and y equals, and you should show this work, 192.675 times 0.933 to the 16th power. So the first one, it's about 24.1 hours, or to the nearest hour, which usually it will ask you to round to the nearest hour in this case, 24 hours. And the second one would be about 63.5 hours, and unfortunately I rounded that, so I didn't round that. So I want to see if it's really 63 point less than 5 or 63.5. So 192.675 times 0.933 to the 16th power, 63.52, so if it's to the nearest hour, it would be 64 hours. This gives me the hours and wants the temperature. So 147 equals 192.675 times 0.933 to the x power. Holy moly. So if I take 147 and divide it by 192.675, it actually turns out to be a rational number, which simplifies to 280 over 367 equals 0.933 to the x power. I'm stuck in exponential form, so I go to logarithmic form. Log base 0.933 of 280 over 367 equals x. Using my change of base formula, x equals the base 10 log of 280 over 387 divided by the base 10 log of 0.933. So the temperature, I'm going to go ahead and take this to the nearest tenth, would have to be 3.9 degrees Celsius for that to work.